Good morning, friends. The topic that today I will be discussing is a digital number system. The digital number system consists of four different number system in computers. The first one is decimal number system. Second one is binary number system. Third one is octal number system, and the fourth one is hexadecimal number system. Now, in decimal number system, the decimal number system is composed of 10 digits from 0 to 9. It is also called the base 10 numbers because it contains the 10 digits. Then comes the binary number system. See, in the binary number system, there are two symbols, 0 and 1. It is called base 2 number system because it has two digits, 0 and 1. The third one is known as the octal number system. The octal number system has 8 unique digits or symbols. They are from 0 to 7. It is called the base 8 number system because it has 8 numbers. The hexadecimal number system. The hexadecimal number system is also called the base 16 number system. This number system uses 16 possible digits. It uses the digits from 0 to 9 and the symbols from A to F, where A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. The next topic that we will be discussing is how to convert a decimal number to binary number. See, in order to convert a decimal number to a binary number, we have to use the repeated division method. In this method, what happens is the number is successively divided by 2 and the remainder is recorded. So I will show you an example. Let us consider a number 206. See, we divide 206 by 2 and we keep on storing the remainder. The number after dividing 206 by 2, the quotient is 103. Again, we divide the number by 2 and we store the remainder. We keep on doing it. Okay, see, till the last number is 1, we keep on doing it, and after doing it we then display the number from the last digit. We start writing the binary number from the last digit to the first digit. If you see, look at the arrow from the last digit till the first digit. So our number is 11001110 from the last to the first. So the decimal number 206 is converted to a binary number 11001110. See, if the decimal number contains a fraction, then what we will do? So this is an example of a decimal number with a fraction. So first we will follow the decimal number without a fraction. So here 206.50. First we will use the repeated division method for 206, and this is how we do it, like the previous one. So for 206 we know the answer is 11001110, and for 50 we multiply the number by 2 and display only the integer part of the number. So when we multiply 2 with 0.50, the integer part is 1, and the decimal after the integer, the decimal fractional part is 0. So the first number is 1, and if I multiply 0 by 2, it will always be 0. So the second number is 0. So the output, the main answer is the decimal number 206.50 converted to binary number will be 11001110. 1110.10. Now I will show you how to convert a binary number to a decimal number. So let us consider the binary number 10110. So we multiply the first number 1 with 2 to the power 4. See, there are total how many numbers? There are total 5 digits. In the binary number there are total 5 digits, 10110. So we will multiply the number with 2 to the power n minus 1. Here n is 5, so n minus 1 will be 4. The first number will be multiplied by 2 to the power 4. So 2 to the power 4 is 16. Then 0 is the second digit. We multiply it by 2 to the power 3. So it will be 0 only. Then 1 into 2 to the power 2, it will be 4. Then 1 into 2 to the power 1, that is 2. And 0 is the last digit. 0 into 2 to the power 0 is 1. Sorry, it is 0. 0 into 2 to the power 0 is 0. Now we add up all this number. So after adding, it comes to 22. So the conversion of a binary number to decimal number is like this. So if the binary number is 10110, the converted form of the decimal number will be 22. Now I will show you how to convert a binary fraction number into a decimal number. Again, the number is 0.1010. So when it is a fractional number, we multiply the number after the decimal point with 2 to the power minus 1. Then we go on 2 to the power minus 2, we multiply it by minus 2, minus 3, like this. So see, the number is 0.1011. So the first number is 1 into 2 to the power minus 1, which is 0.5. Then 0 into 2 to the power minus 2 will be 0. 1, the third number is 1 into 2 to the power minus 3. 2 to the power minus 3 is 0.125. Then 1 into the last number is 1 into 2 to the power minus 4. The number is 0.0625. We add all these numbers and the final result is 0.6875. So the binary number 0.1011 is converted to decimal number and it forms 0.6875. Now I will try to convert a decimal number to an octal number. See, the number, again we will follow the same pattern like we did for decimal to binary, where we successively divided by 2 in decimal to binary. Here we will successively divide it by 8. So let us we have the number 981. So we will start dividing the number by 8 and store the remainder. So if you see properly, you will see the remainders are stored there, 1725. So the decimal number 981 is converted to an octal number 1725 by successively dividing it by 8 and storing the remainder. Now if that decimal number has a fraction in it, so how will we do it? The procedure is same. First we store the numbers, store the remainders, and then for the decimal number we multiply. Now see, for decimal number, for binary to decimal we multiplied it by 2. Now the for decimal number to octal number we multiply it by 8. So here the number after the point was 375. So now we multiply 375 by 8 and the answer is 3.0. We store the number 3 there, and then the decimal number 981.375 is converted to octal number 1725.3. Converting an octal number to a decimal number. See, if I want to convert an octal number to a decimal number, it is also similar, but here it will be to the power 8. Anything to the power to the power 8 will be the base, and it will have the power of the number of digits n minus 1. So here again we have number of digits. The octal number is 12453. So the total number of digit is 5, or we can say n is 5. So n minus 1 will be 4. So the first number will be multiplied by 8 to the power 4. So 1 into 8 to the power 4. So 8 to the power 4 is 4096. It is so 1 into 4096 is 4096. Second one is 2. The second number is 2. Second digit, sorry, is 2. So 2 into 8 to the power 3 will be 8 to the power 3 is 512. So 2 into 512 is our 1024. Then 4 into 8 to the power 2. 8 to the power 2 is 64. So 4 into 64 is 256. And the third number is 5. Sorry, the fourth number is 5. 5 into 8 to the power 1. 8 to the power 1 is 1. 5 into 8 is 40. And the last one is 3. 3 into 8 to the power 0. 8 to the power 0 is 1. 3 into 1 is 3. Now we add up all the numbers and we get 5419. So the octal number 12453 converted into decimal number will be 5419. Now if I want to convert an octal fractional number into decimal number, then what we will do? Again, here again, the first two numbers are your whole number. So whole number will follow the same pattern. 1 2. Then for 5, see, 5 for 5 it will be 5 into 8 to the power minus 1. 512. For after the number, see, after the point the numbers will be divided. The numbers will be to the 8 to the power minus 1, minus 2, minus 3, like that. So the first number is 5 into 8 to the power minus 1. Then 1 into 8 to the power minus 2, that is 1 into 0.01562. And similarly 2 into, the last number is 2, so 2 into 8 to the power minus 3, which comes to around 2 into 0.001953. Then we multiply everything and then we add those numbers together and we get 10.64452. So the octal number 12.512, if I want to convert it into decimal number, it becomes 10.64452. Now I will show you how to convert a decimal number into a hexadecimal number. See, hexadecimal number is of base 16. So again we will have to successively divide the decimal number by 16 and store the remainder. We know the procedure. So this is how we successively divide the number and store the remainder. So the decimal number 564 becomes a hexadecimal number 234. But if I have some let us consider another number, decimal number 31 5. See, I again successively divided by 16. Now when I divide it by 16, the remainder is 11. Okay, so we cannot write 11 because in hexadecimal numbers 11 cannot be written. We have to write it in alphabet. So it is B. Then the next one is 3 again. The remainder is 3 and the last one is 1. So the number will be 13B. So the decimal number 315, if converted to hexadecimal number, it becomes 13B. Now converting a decimal fractional number to hexadecimal number. Let us consider the number 481.03125. So 481, let us first convert 481. We successively divide 481 by 16. Remainder is 1. Remainder is E. And then remainder is 1. 1E1 is the result of 481 converted when I convert it into hexadecimal. Now the point 0.3125, I have to multiply it by 16. So when I multiply it by 16, it gives the number is 0.5. The answer is 0.5. I will store the number 0 as the first number, and then 5 will be my decimal point number. I will multiply 5 with 16 again, and the result is 8. So I will store the number 8. So the final number will be 1E1.08. Converting a hexadecimal number to a decimal number. See the hexadecimal number. Let us consider the example of the hexadecimal number 1243. So I multiply 1 with 16 to the power 3 because the total number of digits is 4 and n will be 4. So the power will be n minus 1. So it will be 3. So 1 into 16 to the power 3. Then then the second digit is 2. 2 into 16 to the power 2. Then 4 into 16 to the power 1. And then 3 into 16 to the power 0. Then we add up all those numbers and the answer is 4675. So the hexadecimal number 1243, when we convert it into a decimal number, it becomes 4675. Similarly, if I have a hexadecimal number 2A3, how do we convert it? See, 2 into 16 to the power 2. So 2 into 256, 512. A, see, A into 16 to the power 1. A is 10. So 10 into 16, 160. And the last one is 3. 3 into 16 to the power 0 is 16 to the power 0 is 1. 3 into 1 is 3. We add up all this and the number that we get is 675. So the hexadecimal number 2A3, when we convert it into a decimal number, it becomes 675. Now if I want to convert a binary number, convert an octal number to a binary number. See, converting an octal number to a binary number. So on the right hand side of this presentation, you will see a chart that is called octal to binary chart. We have to remember this chart. Once you remember this chart, it will be very easy to convert any octal number into a binary number. See, what I did is I segregated all the digits of the octal number in two different parts. The first one is 1, 2, 4 and 3. Now I will try to find out the corresponding values in the table. For 1, the corresponding values is 101. For 2, it is 010. For 4, it is 100. And for 3, it is 011. So we write down the numbers. After writing down the numbers, we try to ignore the first two zeros. See, first two, if there are 0 before a number, before any number, then we can remove those two zeros. So here the answer will be 1 0 1 0 1 0 0 0 1 1. So the first two zeros are omitted and nothing else. Similarly, if I want to convert a binary number into an octal number, let us consider this binary number 100010110111. So what we will do, we will try to group the binary numbers in three portions. Okay, so after grouping, we will group it like this: 11100. From the left hand side we have to group it, not from the right hand side. We will group it from the from the right hand side. So from the last digit we will try to group it in groups of 3 digits. The first one is 111, then is 011, then is 010, and then is 001. So we will try to find out the corresponding values for binary octal digits of the binary equivalent values. So 111, for 111 it is 7, for 100 it is 4, for 010 it is 2, for 110 it is 6, and for 111 it is 7. So our octal number is 4267. Now I will show you how to convert a hexadecimal number into a binary number. Let us consider this hexadecimal number 3A5B. So I have separated the numbers 3A, 5B in 4 different patterns, and then we convert those numbers. We convert those numbers to the binary equivalent of the hexadecimal numbers. So you will see 3 becomes 0011, A becomes 1010, 5 becomes 0101, and B becomes 1011. So our number is this one. Now we can omit the first two zeros. So our number becomes 1110 100 1011 011. If I want to convert a binary number to a hexadecimal number, so let us consider this binary number that is on the screen. We group it into 4 digits. We group it into 4 digits from the right hand side, and then we try to find out the hexadecimal equivalent of the binary number. So the first one is 0100. So 0100 is 4. Then 0101 is 5. So you look at the chart and then you put the numbers. You have to remember the chart. If you remember the chart, it is very easy. So the number becomes 45D7. Thank you very much, guys. I think so you have understood the chapter now. If you have any doubts, please do let me know. Thank you.